Thank you. Yeah, so let's get started. So in this talk, we're going to walk through a practical implementation of a macro. For this, we're going to use a string interpolator for a small JSON DSL as our running example. We're going to implement a string interpolator as a macro first. Then we're going to implement a string interpolator extractor as a macro to support pattern matching. Then we're going to use transparent macro and refinement types to improve the capabilities of the macro. And finally, we're just going to see a bit on how we can do precise error reporting using string interpolator and macros. And these slides and the code that I'm going to show in this project are in a GitHub project. I will share the link at the end of the presentation. So first, if you are not familiar with JSON, the specification says that we have objects, which are name-value pair, a sequence of name-value pairs, arrays, which are sequences of values. We have strings, we have numbers, and we have the literals true and false. But we're only going to focus on objects, array, and strings because numbers and booleans are in the macro implementation are basically the same as the implementation for a string. So this will simplify a bit the code in the slides. So for our purposes, I'm not sure if it's the best design in general for an actual library, but to show macro the features, we're going to want to have a precise type for each JSON value. So we want a type for string, for object, and for array. And we're going to use the normal Scala string for strings. And we're going to define custom JSON object and JSON arrays. And we're going to define JSON as JSON object or JSON array or JSON string. So the JSON array is extremely trivial. It's just a wrapper over a sequence of JSON values. And we have the apply and the length. And yeah, we all know how to use that because it's basically an array, an immutable array. For objects, we're going to do something similar. We're going to wrap a name-value map. But this time, we're going to use the Scala Selectable to have a bit more interesting features. And so we need to implement the select dynamic method on Selectable. And this method will take the name of the property of the JSON and will return a JSON value or undefined, just to follow a bit the notation of JavaScript. And we define undefined down there. We're not going to really use undefined at the end, but it's going to be there just as a placeholder for now. And I specifically didn't use an option here because that will not play well with refinement types. So the slides that are in dark are mostly background on Scala and concepts that we need to use, but not really the code that we're implementing. So here is a bit of background on the Scala Selectable. So if we have an object that extends Scala Selectable, and we're going to access a member that doesn't really exist that is not defined on that class, then we're going to call the select dynamic instead and give the name explicitly. So for example, if we have a JSON object .name, we're going to instead call JSON object the select dynamic of that name as a string. And then at runtime, we can figure out what to do with that. We can do something similar with dynamic apply for function applications, but we don't need it for this API. And we can also use refinement types, which we'll see in later slides. So the first step is to implement a JSON macro interpolator. So we want to define some JSON string interpolator like that, where we can define a JSON value inside, which will return a JSON, and we're going to check that this is a valid JSON and return the correct object. And we can also compose them as easily. So the first thing we need to understand to implement the macro is how a string interpolator works under the hood. So when you have a string interpolator like this, it's going to sugar into a call to string context, which will create and wrap the string parts of the string interpolator. And then we'll call a method on it, passing all the spliced arguments. So in this case, we're going to call the JSON method and pass all the arguments, the first and second talk. And usually this is implemented as an extension method. We also need to know a bit about multi-stage programming. And so here the idea is that we want to represent code as values in the program. And here an expr of string represents code that will evaluate to something of type string. We can instantiate or create expressions using the quotes. So this quoted block will just delay whatever code is inside of it to be evaluated later. We can also compose them using splices with the same notation that we use for string interpolator to compose in the same way. We also have another operation which is lifting a value. So if we have a value and we want to create a copy some code that will create a copy of that value in the next stage, we can use the expr constructor. So now with this, we can also implement macros by just defining an inline method. And instead of having a quote, we're going to start with a splice that is outside of a quote. So whenever this call to hello will be inlined somewhere, the contents of the splice will be evaluated at compile time, and whatever code is generated by the call to hello expr will be inserted in its place. So now we have everything we need to start implementing our macro. Here we define an extension method on our string context, and we define an inline method on called JSON that will take any number of JSON args. We make the string context inline because we don't want to actually instantiate it at runtime. We just want to have it at compile time to look into it, to figure out what the string parts are, and then we are going to generate some completely different code. And for the inline args, we also want to inline this because we don't want to create essentially the sequence of those var args. We will just take each individual var args and put them in the code directly. Now we can have a look at how we could implement this macro. So here we're going to have the implementation of the macro with JSON expr, which will take the expression representing the string context and an expression representing the sequence of var args. The first thing that we need to do is to figure out what's the content of the string context. So we're going to parse the contents of the string context into something that we're going to call a pattern. This is basically an AST of the contents of the string pattern. I will go into it a bit later, and it is extracted from the string context parts. Next, we want to take this var args and convert this expression of a sequence of JSON and figure out each individual expression and split this expr of sequence of JSON into a sequence of expressions of JSON. And for that, we have these extractor var args. Here I'm using a val pattern rather than a pattern match, just because it's smaller on the slides. But usually we should write args match and then the case var args, and handle the case where the user didn't pass it explicitly, for example, if they use unpacking. But because we were assuming that they wrote the string interpolator explicitly and not a string context, then this should always work. And finally, we need to compile this pattern and the arguments into some code. In our example, we want to generate this JSON array receiving the arguments directly. So this is the basic implementation. We need to go into the details of how we're going to parse this. So the first thing we can do with a string context is just ask for its value. So this value or abort will take the expression of a context, and if it's a known value, it will just return us the string context, and if not, it will stop the evaluation of the macro and report an error saying that it was not statically known. And for this to work, we need a from expr of string type class, which implements the actual unlifting of this value. We can do similar things with the value method or the expr extractors in pattern position. Next, we can extract the parts of the string context and handle the escape characters that we don't have really in this case. And finally, we have a sequence of strings, and we need to parse them. So we're going to call a parser. The parser will either succeed or not. It will and it will return us a pattern AST. I'm not going to go into the details of how to implement the parser because it doesn't have any macro things inside of it. So we're just going to assume that we have some implementation for that. Now, a pattern will just be a string that contains its value, an array of patterns, or an object of name-value pairs. But this time we're going to have a sequence rather than a map because we really want to keep track of what the user wrote and in the order, just in case they defined twice the same name. We should be able to distinguish those cases and report an error. And finally, we have the interpolated value, which represents wherever there was a splice somewhere in the string interpolator. So, for example, if we have this JSON string interpolator, we can parse it and get this object that has an interpolated value where the splice was and has a string for the two that was in a string, and the names are kept as strings. Okay, so now we know how to do the first two things. Basically, we need to do the last part, which is compiling the pattern and the arguments into JSON. How can we do that? Well, we can easily recursively transform this by traversing the tree. And the first case is relatively simple. If we have a string, then we can take the value of the string, lift it into an expression using the toExpr type class. If we have an array pattern, then we can recursively lift each pattern in the array, and then we can use the varargs again, but this time to take the sequence of expression into an expression of sequence that we can use to splice into the array constructor, and we're going to unpack those values as varargs. And then we have the object, which is really similar, but now we have to lift the name and recursively lift the value. But then we have an extra step, which is we have basically a sequence of tuples of expressions, and we want to make a sequence of expression of tuples. So we have this expr of tuple that helps us take any tuple of expressions into an expression of tuple. And then we do the same with the varargs and calling the constructor of the JSON object with the varargs. And lastly, we need to handle the interpolated values. Because we know that the traversal order is the same as the argument order, and we know that we're going to see each interpolated value exactly the same number of times as the arguments, then we can just use an iterator and just ask for the next one. And basically, this is the full implementation of the compilation part. So now we have all the code that we need to know how to implement a string interpolator as a macro. Good. So next, we want to implement an extractor for this JSON interpolator. So we have to go back to the string context and see how that works in patterns. So on one side, we have an expression, and on the other side, we have a JSON as a pattern. But they will both get desugared to the call to this JSON with the arguments. So now the trick is to, instead of defining the JSON as an extension method for the macro, we're going to use it as an indirection to get to something that has an apply method and an unapply method, and both of those will be the macros. So we can do that by just defining a type, what we're going to call JSON string context, which is a wrapper on a string context, and we'll define our extension method to define the string interpolator name, JSON, and it will just return that JSON string context. And we're only going to use this at compile time, and the macro will take care of removing this call. And then we can just implement our two extension methods on the JSON string context, basically in the same way as we did before. Now we have the apply instead of the JSON method, and we can add the unapply seek in this case because we want to be able to extract any number of JSON values from the pattern. And we can implement them in the same way as before. So before we go into the implementation, let's have a look at multi-stage programming and pattern matching. So we can use pattern matching to match against expressions to see if an expression is equivalent to another. So here we're checking that this expression represents the code hello. But we can also extract parts of the expression. So here we have a hello plus something and we are going to extract the name of whatever is there. And so here the splice symbol, instead of meaning that we're going to insert something in this quoted code, we're going to extract that something. And we can use a type ascription to explicitly say that this expression is of that specific type. That's useful when we have ambiguities with overloading, basically overloading. So now we can go back to our previous implementation on the JSON exper, but we will need to change this exper of string context into a exper of JSON string context. So what do we need to do? Basically, we can just do this, where I'm again using a quote pattern, but in a val, as a val extractor, just because I wanted to keep it short, but it would be better to do a pattern match. But here what we're saying is that this JSON SC exper should match some string code that has a string context and calls the JSON extension method. And we're going to extract the string context. And then once we have this the string context exper, which is our JSON string context, we can just reuse the same code as we had before. And that's all we need to change in the JSON exper. So now we can have a look at what we can do with the onApply. Because we want to parse these string context, we can reuse exactly the same logic to get a pattern that represents the AST of what's inside of the string context. But then the question is, what are we going to do with this pattern? One simple thing that we can do is, this pattern basically represents a pattern, and that's why I named it pattern. So we could take that value and put it in the program at runtime and just use it for the pattern matching itself. So we could just lift it and use it as it is in the next stage. And to do that, we can just define an onApply seek method on pattern and just insert the creation of the pattern in code and the scrutiny, so we can call the onApply explicitly and do the pattern matching. I'm not going to go into the onApply seek because, again, it doesn't have any macro implementation details. But that's basically all we need to implement an onApply seek. But there is one thing. I said that we were going to leave the pattern, but we need a 2exper of pattern to do so. And the standard library doesn't define one because it doesn't know about pattern. So we can define it easily ourselves. Case by case, we can lift the interpolated value just as the interpolated value again. We can state the string pattern and insert the lifted representation of the string value, and basically exactly the same for the arrays and the objects. But here the type class that we're using is the 2exper of seek or 2exper of tuple2 to lift those tuples and sequences from the varargs. And as usual, they compose amongst themselves. So now we know how to implement string interpolator extractor with macros. Next step will be to refine the types. So what we want is to be able to write something like that, where, we have this JSON, we know that the JSON has a name and has a speaker, and both are strings. But right now, this JSON string context returns a JSON, which means that we don't even know that on second talk we can call name, because we don't even know that it's an JSON object. And even if we did know, then we wouldn't know if this name would be a string or something else, because we return JSON or undefined with a JSON object. So to do that, we're going to use a feature of Scala Selectable, which is the combination of Scala Selectable with refinement types. So if we have something that is Scala Selectable, and we refine the type, then we are giving the compiler all the information it needs to know what's the type that this object will have. So in this case, we can refine the JSON object with the val name string, and now we can just say, yeah, JSON object.name, and we know that it's going to return a string at runtime. And it still calls this, but it still calls the select dynamic to actually do the operation. So now we can use it on our example. We want this JSON to actually have this type, JSON object with fields called the name that is of type string and fields called speaker of type string. But we can do something similar for JSON arrays. But in this time, instead of adding new members in the refinement, we're going to refine the type of an existing method, the apply method. And we are going to say, on this particular JSON array, if you call the apply, you're always going to get JSON object with those refinements. So the first step to do that is to define the macro as a transparent macro. So this will make a difference in how the code is expanded. We are going to first expand, whenever we expand the code, whatever the result at the call site will not be a JSON, but whatever type of the expression that we're going to inline. And we can do something similar with the unapply, but this time we should use an unapply instead of an apply seek and return an option of tuple. The important thing is that we need to return some expression that has a known tuple size for this to work. So this is the previous implementation where we compile just the pattern and the JSON, and we used to just return a string, a JSON array, or an object. This means that with the transparent, we're already refining to those three types. But we want to do a bit more. We want to be able to refine them to JSON of val name of string or JSON of array of apply with an apply method that has a known thing. So we can compute in the macros those types. So what is this type question mark? This is basically a runtime representation of the type T, and we can construct them using the type of, which either takes a statically known type or some type for which we have an implicit type of T. Or it contains parts that are static, parts that are known by some implicit, like the list of T that composes the list and with the type of T. We can do something similar with pattern matching, where we just take the type and pattern match against the type to check what the actual value of that type is. So you can pattern match to check if it's a statically known string or a list of some T, where a T is a type variable that we don't know at compile time, but we're going to extract from that type, and then we can use on the right-hand side of the pattern. Or we can just say that this type is some type T, just a type variable. This last one is quite useful, even if it looks a bit weird, because we can just use it to take this type of question mark, which we have no idea what the name of this type is, and give it a name and just say, this type is called now T. And now we can use it in coded patterns to just say, oh, the expressions that we compiled before, we're going to cast it to this specific type, lowercase t. So in naming the type is one of the, I would say, most useful things about type patterns and type variables. Now we can have a look at how we actually implement this creation of our refinement type. We're going to do it in two steps. We're going to take the pattern and the arguments and create a schema from that. And then we're going to take that schema and we're going to compile it into a type. We don't know the type statically, so that's why it's still a type of question mark. And the schema will look like this. It's either a JSON, which is basically any JSON value, a str, which is a string, an array of a schema, of some specific schema element, or an object of field names and their schema. how do we implement the schema? How do we take the pattern and the args to create the schema? We can again do it recursively on the pattern, and if we have a string, then we know that the schema is a string. If we have an array and it's empty, then yeah, we can use any value, any type. So we're going to choose a schema for array of values. I could have added a bottom type to represent this, but I followed what JSON had. And then if we have an array of many elements, then we can recursively get the schema of each one and then do some union on those schemas. Here the union is trivial. If you have two strings, you get a string. If you have two arrays, you will get the array of the intersection of not the array. Yeah, the array of the union of those schemas. And if you have objects, something similar. And for objects, we do something really similar. We just take the name values, but only recurs on the values to get the schemas of the values, and then we can create the schema from that. And lastly, we have the interpolated value. Well, if we're lazy, we could just say, oh, if you have an interpolated value, we don't know it because it's not statically known in the string. But we can do better than that because we have the arguments and we can look into the expressions of the arguments. So we can get the argument corresponding to that interpolated value. And this time, we're going to use pattern matching, not to decompose the code, but just to match the expression to itself and extract this expression. We're not going to care about the actual expression, the args expr, but we're going to care about the t, which is again a type variable like we saw in the type pattern matching. But this time this t will be the most precise type of this expr, and we can use it to figure out what type this expression has. And so we are going to define another method, which is the schema of some type, that will give us the schema for that type. And to implement that, we're going to use pattern matching, this time on the types directly to extract the information out of the types. So the first case, if the type is string, then we're going to use the schema of string as always. But this time, if it's a JSON array, then we need to do a bit more, and we're going to use reflection to figure out what's the actual schema. So here we're going to go into the unsafe parts of the API. And the idea when we use the reflection, or the good practices, is to not to use it in a small scope and not leak it into all your code, so that you can keep the unsafe parts kind of well bounded. And here we're going to use this type wrapper instead of type, which is basically the structured type representation of that type. This one is not parameterized by its type, so it doesn't know statically what type it is. And we widen it just to get to the refinement in case there is some indirection between the type, like an alias or some other thing, or singleton types. And we get to this refinement, and if you have a refinement of the apply method, then we want it to result type. We can take this result type, convert it back to a type of question mark, and now we again use this quote type pattern matching to get to name this type lowercase t and use it recursively in our schema of. And once we have the schema of the element type of the JSON, we can just create the schema of that array type. And we do something almost identical for objects, just that this time we have to do it recursively and go recursively into the parents, because we can have many refinements nested one inside of another, which represents all the refinements in the sequence of refinements that we have in source. And if it's none of those cases, then we just say it's a JSON value, because we don't have enough information to know anything statically. So now let's see how we can take this schema and create it a type again. For values and strings, it's trivial. We can just use the constructor type of to construct those statically known types. for arrays, we can recursively get the type of the element schema, name it, and then use a type constructor in a slightly different way, because this time we're going to use the JSON array, we're going to refine it, and we're going to insert this lowercase t type that we extracted from the recursive call to refinement type. And for the object, we do need to use reflection because we don't know statically the names of the refinements. So we're just going to fold over the JSON object, and we're going to add as many refinements around it as we have in the schema. And for each schema, we're going to just use the name and again recursively get the type out of the schema for each of the key values. And yeah, this is the full code, not too long. So now we know how to use type refinements in macros to implement something like this. The last thing we're going to see is how to do precise error reporting. So we basically here, I made a mistake. Instead of using the colon, I use an equals because it felt natural. So probably I should emit an error saying, oh, here I was expecting a colon instead of an equals. So to report errors in a macro, first we need to figure out where are we going to report this error on. And we know that the string context had these three parts that are strings. So we have this part 0 with part 1 and part 2. So we can name our error location as the index of the string in the string context, and then some offset within that particular string in the parts of the string context. In this case, it's the part 1 and offset at 12 characters. So let's go back to how we did the parsing. The parser returned us a parser error with some message that is a string and a location that is exactly this location. So one thing that we could do is just ignore it and just report the error using the reflection API and just say, oh, I want to report this error, and if without any positions, which means basically the position where we expanded the macro, which is the full position of the string interpolator. But of course, this is not a good idea because we have more information. We can take this string context, decompose it, figure out all the the parts of the varargs to get the expression of each of those string parts, and then we can choose the one at index 1, and finally we just report the error on this expression, and this would emit this kind of error. We basically implemented this where we got the part of the string as an expression, and we just passed that to the error message. So now what we can do is go deeper and use this offset. So using reflection, we can construct specific positions. So here the first thing we need to figure out is what is the source file of the position, so we can take any of the expressions that we have, call as term on them to get their AST, then we can check for their position and get the source file. Then we can get the base offset of the string part that we were compiling, so basically this offset, and add it to the offset that we have within it, so basically computing this offset plus whatever came before in the file, and then we can reconstruct this position. So here, to construct the position, we have the source file and two offsets, because this position is a range, so I chose to only have a single character position, but we could have some longer one. And well, now we have everything we need to do precise error reporting. And thank you, and back to questions, I guess.